Today we're going to be studying graphing again, but this time we're going to be stretching our graphs. Our goals are still the same. We'll be able to graph parent functions, shift parent functions, and we're going to add stretching into the equation. First, let's review our parent function. F of x equals x squared. That's a quadratic function. The important points are at 0, 0, 1, 1, and negative 1, 1, and it creates a U shape. F of x equals x cubed is a cubic function. Its important points lie at 0, 0, 1, 1, and negative 1, negative 1. It creates a squiggle shape. An absolute value function is similar to that of a quadratic function because important points are 0, 0, 1, 1, and negative 1, negative 1. But it creates a V shape. The cube root function has three important points at 0, 0, 1, 1, and 4, 2. And the final function that we need to consider is our step function, or our greatest integer function. This is the function that has both open and closed dots in it. And that's our parent function. Again, make sure you have these memorized and you know how the parent functions work. There are two different ways to stretch a graph. You can stretch it vertically or you can stretch it horizontally. If you are vertically stretching, the y's are either going to get closer together or further apart, depending on the value that you are stretching. You know you have a vertical stretch when there is a constant number being multiplied by the function. For example, 3 times the absolute value of x. This 3 will stretch the graph vertically. We will multiply every y value in this function by 3 to give it the stretched shape. Horizontal stretches are a bit different. This time the x's are getting further apart or closer together, depending upon what the number is. The number this time is being multiplied inside the function. So perhaps something like this, the absolute value of 3 times x. The points change a bit differently. You're going to multiply this constant number by the x's, but you actually multiply by the reciprocal, 1 over c. So in this particular situation, we would be multiplying all x values by 1/3 to get our new shape. Let's try an example. F of x equals 2 times x cubed. So first, I know this is a vertical stretch because the 2 is not inside the function, like this. So I'll begin with my parent function. I know a cubic function has important points at 0, 0, 1, 1, and negative 1, negative 1, and creates the squiggle shape. Whenever I have a vertical stretch, I find it helpful to write out my important points. I do this because I'm involved in a process where I have to multiply. Since this is a vertical stretch, every single y value is going to get multiplied by 2. So the point 1, 1 is now the point 1, 2. The point 0, 0 is going to stay the same. And the point negative 1, negative 1 is going to become negative 1, negative 2. I'll plot these points in my coordinate plane. And the purple graph is my final function. You don't necessarily have to write this out if you can do it in your head, but I do find it helpful to write out the points. Let's do another example. This one is g of x equals the absolute value of 1/2 x. So I'm going to start off by focusing on my parent function, the absolute value of x. So I know that my important points of this parent function are 0, 0, 1, 1, and negative 1, 1. And it creates the V shape. And again, I find it helpful when I'm dealing with stretches to write out my points. Now, since this 1/2 is inside of the function, as opposed to outside the function like that, this is a horizontal stretch. When I'm doing a horizontal stretch, I multiply by the reciprocal. Since it's a horizontal stretch, it's the x's that I'm going to multiply. The reciprocal of 1/2 would be 2. So every point is going to change by multiplying the x values by 2. So 1, 1 becomes 2, 1. 0, 0 stays the same. And negative 1, 1 becomes negative 2, 1. So I'll plot my new points. And that's my function. My final graph would be the blue. Please write down any questions that you have, and we will continue this lesson in class.